Series 3000 Baltimore air coil, very common cooling tower for both commercial and industrial applications. This system had a water treatment provided by WCTI Systems through Waterside Asset Management, and it's a little bit unique in that it has a high silicate content in the water, high dissolved solids, and overall things inside look pretty good. The water treatment was implemented after the towers had been in service for quite some time. So corrosion that you see here had started prior to that water treatment. But if you look down in the basins, it's very, very clean. We didn't find a lot of corrosion in the basins, but we do have some on the sidewalls. So this tower is going to be sandblasted, and we're getting it set up now to do that process. The next image I show you will be after we have the containment done, and I'm going to show you what's required for proper containment and environmental control for QC applications. So regardless of what type of coating you put in a tower, the environmental control is critical. And at minimum, read the manufacturer's instructions on that coating product, whatever you decide to use, and apply it per the manufacturer's directions. And also record that substrate. When you're done with your preparation, have someone come in and inspect it to verify that it meets that criteria for the manufacturer. And then when you're done, do a holiday test on it to make sure that you have absolutely 100% coverage at the specified mill thickness that you're looking for. This particular application, we're going to be using a polyurea application for the lower basin and the sidewalls. And on the hot decks, we're going to be using a brushable material that has a little bit of a thinner mill thickness coverage so that we can snap the nozzles back in. Otherwise, you have too much thickness of the coating, you won't be able to get them to fit properly back in the deck. With that said, the reason we're going with that system is we're going to put 70 to 80 mils of tank lining on every surface in here that's exposed by the fill areas and 3 inches above the basin. That forms a monolithic structural lining that if there was ever a failure, guess where it stays? Right in the tower. So it's not going to disbond, clog downstream systems, flake or blister in that method where that blistering will disbond. You got a solid mill thickness of material close to 1/8 of an inch. That's why we like it. We've tested these products for 10 years now, and we're testing a formulation on this particular system that has a very high chemical resistance to it and should provide many years of service for this cooling tower. It's important because it's very expensive to come back in, take all the mechanical components back out, take the fill media back out to make repairs. And like I said before, you can damage downstream systems by having failures. So failure mode of epoxies would tend to be a flaking. Failure mode of brushable elastomerics would be blistering, rust bloom, and disbondment from the coating. Failure modes for tank linings would be a disbondment, but that's where it would stay. So you would cut it out and reapply in that area, but you don't have to necessarily worry about it going downstream or sheet peeling and covering over your strainers. And if strainers get entirely encapsulated by a coating sheet, they'll collapse and go right down through your piping systems or other, it causes problems. At minimum, it would be an overflow situation or therefore. So we're going to walk through this tower. At each stage, we're going to show you the QC methods that are required to get ultimate longevity out of cooling tower systems.